Hello guys, and welcome back to Learn Coding Skills. This is the second video in our text preprocessing with Python and NLTK series, and today we'll be looking at stemming. So of course we must first ask, what is stemming? So the definition that I've put together is that it's the chopping off of the ends of words in order to combine variants of a word into a singular reduced form. We'll look at some examples in a moment, but first let's look at where stemming can be used. So first of all, we can use it in a search engine where we use information retrieval to obtain the documents. Let's think of an example. So if a user types in games console, we would like for there to be similar results as if they were to type in gaming console. So games and gaming would both be stemmed so that wherever they appear in a document, they'll be seen as the same. Meaning that whenever we search for games console or gaming console, we should get the same results. Another example is in chatbots, and this is really the same thing, in which we want our chatbot to be able to understand that certain words are similar. And one of the main benefits of actually doing this is that it will make our algorithms a lot more efficient. And this is more pronounced where we have multiple morphological variants. And then also in sentiment analysis, because this means that overall similar words will have a similar sentiment value. But there is a caveat though, which we'll discuss a little later on. So yeah, in general, stemming helps with word matching. So let's look at this example. This is a pretty simple one. We have play, playing, played, and playful, and these will all truncate into play. So we take off all the ends of playing and played and playful and just make it all play. So wherever these appear in a document, they'll all be seen as play. And another one, connect, connected, connection, and connecting, all truncate into connect. Okay, here's an example that you can try yourself. This one is slightly different to the others, but it will get you to think about how stemming works. So I'm not going to reveal the answer, but if you think you know, then you can write your answer in the comments. So now let's look at the advantages and the disadvantages. So the first one is that we can produce more relevant results. And the reason for this is that I'll go back to my initial example of the games and gaming console. If a user types in games console, they'll be able to find documents that have gaming console. If we didn't have this, they could type in games console, and then there could be a document out there that's pretty relevant, but it doesn't say games console, it says gaming console. And because those are two different words, it wouldn't have a good match. But with stemming, it would have a good match. So overall, it helps to increase the amount of relevant matches that we get. And then, yeah, as I said before, it makes it more efficient. So yeah, the number of unique words in the dataset is reduced, which obviously makes it more efficient to search. The index of the words in the vocabulary and the associated documents, and then obviously reduces storage requirements because, well, there's less words. But there's one major downside to stemming, which is that in some cases, it lowers accuracy by changing the meaning of a word. An example of that is better will be truncated into bet, which means that the word bet, which obviously won't be truncated at all, and the word better, which will be truncated into bet, will be seen as the same thing. But they have completely different meanings, which can be an issue. But this is something that lemmatization can solve, which is similar to stemming, but it adapts words based on their meaning. But we'll talk more about lemmatization in another video. Time to get into some code. So we'll begin by importing our stemmer from NLTK. From NLTK, import port stemmer, which is the name of the stemmer that we'll be using. And then we'll say stemmer equals port stemmer. And let's just make sure that all works. It does. We'll use our play example for our list of words. Nice. Now to stem this list is pretty simple. We'll use list comprehension to make it even more concise. So let's print it all in one go. Stemmer.stem word for word in words. So for each word, just stem it and store them all as a list. There we go. So have a go with this yourself. Try different lists of words and see the results you get. I hope that this video was useful, and if it was, please drop a like. If you have any questions, ask in the comments below, and subscribe for more content. Thank you for watching.